Hey guys, welcome to my channel. I do not like CP, where we solve competitive programming problems which we don't like that much. So yeah, let's quickly start today's video. So today's question is, find the minimum number of swaps needed to sort an array containing the integers 1 to n, right? So let's see क्या है ये question. So हमारा input है, 1 second, sorry, हमारा input है एक array, right? For example, 3, 1, 2, 5, 4. So it has the numbers containing from 1 to 5, right? So n is equal to 5. Okay. Now the problem states कि हमें इसे sort करना है by swapping elements, right? Now swapping का मतलब क्या होता है? Swapping means changing the positions of any two elements with each other, right? For example, if I swap this by this, then my array would look like 2, 1, 3, 5, 4, right? Similarly, if I again swap kind of this element and this element, right? So then my array would look like 1, 2, 3, 5 and 4, right? So now again, if we swap these two elements, right? So this would look like 1, 2, 3, 4 and 5, right? That way we have sorted it completely, right? But the problem is we have to find the minimum number of swaps. We can be like, you can keep swapping probably the same elements again and again, and probably it's not the most optimized way to sort the array, right? So we have to find the minimum number of ways. So let's see. So before we jump into this algorithm, first let's try to understand the concept of cyclic sorting. Okay, so let me just erase that. Right. So what is cyclic sorting? So cyclic sorting is a sorting algorithm which says that you can, if you keep swapping the elements with their, if you keep putting the elements to their correct position, right, you will eventually form a cycle and all the elements within that cycle would be sorted, and then you move ahead and sort the remaining of the elements by swapping, right? This algorithm runs in O(n) time, right, and it could be pretty fast if you have a range of numbers given. Okay, just like I showed you here, like if we keep swapping, right, we will eventually put the elements in their correct position. So now let's try to see how the cyclic sorting would work here, right? So let's start with the first element here, right, from here. So now if I swap this to its correct position, what would be its correct position? Its value is 3, so its correct position is 3. So it's 1, 2, 3. It should come here, right? So I'll put this one here. Similarly, 2 would go here and then 1 would go here, right? So eventually it would become 1, 2 and 3, right? So this part is sorted, and if you see, this forms a cycle, right? 3 to its correct position, 2 its correct position, and then 1 to its correct position. Similarly, for the remaining elements, we can start with like 5. So 5 will go here, 4 will go here, right? So this would form a cycle. Now let's see, is it necessary? Like you can argue that that this may not form a cycle, right? So let's just try to see if that's possible, right? So for example, we are not. Let's assume that it doesn't form a cycle. So it means that we're putting all of the elements to the correct position. So it will come from here, then from 2 to 1, and then 1 to 3, right? And then suppose, so this forms a cycle. Let's see it doesn't form. Let's say it doesn't form a cycle. So 3 would go here, 2 would go here. Now it would mean that 1 cannot go here. So it has to go to some other location, right? For example, it has to go here, right? And then from here, this one would go here, right? And now 4. Now what is the, so it means that if it goes here, it will definitely form a cycle, right? If it doesn't have to, if we assume that it doesn't form a cycle, then it has to go somewhere else outside the array, which is not possible, right? So that's why by induction we say that we cannot have acyclic graph here, right? So it means that the longest cycle that I can form is like this, and then this, and then this, and this. Suppose it was like that, and if from here, if we don't want to go back, right, it will mean that they have to go somewhere outside, right? but we just have 5 elements in this array. So hence it has to form a cycle. But then you can also argue that the cycle doesn't have to be from the first element where we started. If, for example, I started from here, you may say that, okay, what if the cycle goes somewhere here, right? But again, that is impossible, because by saying this, right, it means that the correct position of 3 is here and the correct position of this is here. Don't I go to by the value of, right? I'm just taking an example. So it has to go here, this has to go here, this has to go here, this has to go here, and then if I'm saying that it has to go somewhere here, it means that we're trying to place 2 different elements at the same position, right? Which is again impossible. So it has to end at its starting position, right? So hence we can clearly prove that by swapping we'll form a cycle. The cycle will always end at the start of the swapping, right? So that's how the cyclic sort works. Okay. So let's see now. Let's get back to the question actually. So we need to find the minimum number of swaps. We need to sort an array or sort this array, right? So if you look at it, right, if you keep swapping the elements, right? If you keep putting the element to its right position, right, it will eventually form a cycle as I mentioned. So what will be the so how many swaps are needed to form that cycle? For example, let's take an example here. So this will go here, this will go here, and this will go here, right? So this is a cycle. Okay. Now, how many swaps are needed for this, right? Let's see. So suppose I'm swapping this, so it would become 2, 1, and 3, right? So this is now at its correct position. Now I'm still at the first position. Now what is the correct position of this? 2. So I put this one here, right? So now this comes here, and this comes here, and this comes here, right? So now 2 is at correct position and 1 is now at its correct position. Now similarly for remaining, we'll put this one here, and then 1, 2, 3, 4, 5. So this is sorted, right? So how many swaps did we have to do to solve this part, right? 1 swap, 2 swap, right? Similarly here just 1 swap, right? But if you look at the cycle formed by this, both of these, so cycle was this, and this, right? And similarly this and this, right? So you can say that the number of swaps needed for sorting one cycle of elements is the length of the cycle minus 1. So this was 3, right? 1, 2, 3. So it required 2 swaps. Now this one has 2, the length of cycle is 2. It required 1 swap. So that's the algorithm, right? So the point is, if you want to, so let's now get to the solution of it, right? So now if you want to kind of sort it as you go, right, then what you can do is you can keep placing the element to its correct position. So it will put 3 here, right? So it would 2 would be here, 1, 3. So swap first element, right? Then again, so we'll keep swapping unless the element at my current position is the correct element, right? So I'm at the first position, the correct element at the first position is 1. I'll keep swapping until I get 1 at the first position, right? So again, the first position is 2, so I swap it here. So I get here 2, 3, 5, 4, right? So count, and okay. So swaps initially was 1, right, for this, and now swaps is equal to 2, right, for this one, right? So now this part is sorted. Now I move ahead one by one. So this is correct, right, at correct position. This is again at its correct position. This is again at correct position. So we don't need to take care of that. Now this is at wrong position. So now from here we put it to its correct position. So this is 1, 2, 3, 4, 5. Now swaps is 3. So this is the minimum number of swaps needed. So either we can keep swapping, right, or you don't even need to swap. You just need to count the cycle length, right? So from how do we do that? So again, let's take the initial array 3, 1, 2, 5, 4, right? From here we go to the, so what we do, we just jump from one position to another until we get back to the original location, right? So from 3 we go to here because the correct position of 3 is here. Now go to, this is 2, so let's go to the second position, and this is 1, go back to the first position, right? So this is now it at original location. We started from here and we ended here. So what is the length of the cycle? 1, 2 and 3, right? So swaps is equal to 3 minus 1 is equal to 2. Now the array becomes, now we just we ignore these, right, and we come here. So now how many, so it becomes, suppose that it becomes 3, now it is 5 and 4, right? So we again start from 5, we again start from 5, we go to 4, and from 4 we go to 5. We have come back to the original location. The length of our cycle is 2, so swaps is equal to, swaps plus is equal to 2 minus 1, right? So total swaps is equal to 2 plus 1 is equal to 3, right? So that's our answer. Alright, I hope you got the the idea behind this whole swapping thing, right? And that's this logic can be used in multiple types of problems, right? One is like if you have been given, अगर आपको एक इनपुट आई दिया है जिसका एक रेंज में वैल्यू है, फॉर एग्जांपल हमने भी डिस्कस किया है 1 to n का, but we can easily modify it to handle from A to B, right? If there is any array which has a range of numbers from A to B, it can be sorted in O n time using this sorting algorithm, right? So there are different kinds of problems which are based upon this swapping technique, and that's how using this technique we can solve those problems. Now let's go and check out how the code looks like. Yeah, so let's see how the code looks like. So here is our problem. We're given an unordered array consisting of consecutive integers from 1 to n and without any duplicates. Yeah, that's an important part. The array cannot have duplicates, and we're allowed to swap any two of the elements, and we have to find the minimum number of swaps required to sort the array in ascending order. Now let's quickly jump into the code and see how this looks like. Okay, so this is our function and we're given an input array of integers. Okay, let's start by finding the length of the array. So this array dot length. Right now, what do we have to do? We have to first initialize an answer. Let our answer be 0, right? And we'll also initialize an array. Let's call it corrected, right? This will be all initialized to false. So we're keeping this, we're creating this array just so that we can keep track of those elements which have been corrected. Right? Since we won't be doing an actual swapping of elements, right? So while we do cycle, right, how do we know that this element has already been part of a cycle, right? So that's why we store this, that this has already been corrected, so you won't retry the same integer again. Okay. Now let's start a loop from and pause is equal to 0, pause will be less than n, and pause plus plus. Okay. Now when would we start actually the loop while swapping? When we find that an element is not at its correct location, right? So if arr pause is not equal to pause plus 1, right? It is not equal to pause plus 1. Since this is a zero indexed array and the numbers are from 1 to n, that's why pause plus 1, right? And if it is not at the correct location, it's been corrected. It means also we have already gone through one cycle and have counted a cycle, then we need to skip it. So, and not corrected, pause. Okay. Cool. So now we'll do initialize cycle. Cycle is equal to 0. It will contain the cycle length, right? And initialize something called temp just to move across the cycle. A separate pointer. We point to pause, and we'll do while not corrected temp, right? So what we'll do corrected temp is equal to true, right? We'll do cycle plus plus to count the cycle length, and then we'll do temp is equal to arr temp minus 1. Why minus 1? Again, because it's a zero indexed array and the elements are 1 to n, right? And if it is there, then we do answer plus equal to cycle length minus 1. So answer plus equal to cycle minus 1, right? And that's our final answer. So we'll return answer. Okay, so let's just go through it quickly. So yeah, we're getting the length of the array, we're initializing answer to 0. We create a boolean array, right? Okay, the size is not given, so size would be n. So for each of the elements, pause, we start a loop, right? So we check whether the element is not at its correct location. It either is that, right? Not either, like it has to be that element is not at correct location and it has not been corrected before through a prior loop or prior cycle, right? So we initialize cycle length is 0. We start initialize a separate variable, a pointer, to move across the cycle, and we will continue or we'll start a loop again until we find a corrected value. So when we start from here, we'll correct that and we'll go back and we'll move back to the initial corrected one. That's the logic. So we'll do correct temp is equal to true. The first element is now corrected. So now after that, if we go back to an element, find an element which is corrected, then it means we have completed loop, right? So the cycle plus plus and the temp would be, we'll move to the next. So mine is, for example, first is 3, so we'll move to the second position and check what is the element there and then continue, right? And then once that we have completed one cycle, then we'll add that cycle minus 1 length to answer, and that's our answer. Let's see if this actually runs. So it is this. So yeah, the sample test cases have passed successfully. Let's submit the code. Yeah, so all the test cases have been passed successfully. So yeah, that's our code. If you look at it, the code is pretty simple, but the logic behind is important. So I suggest you to go again, try it yourself, right? Try to understand the logic behind it, and then try some questions which are related to swapping. This will really help you in other swapping based problems, more complicated problems. Yeah. Alright, that's it for today. Thank you for watching the video. We'll come back with some new videos soon. Bye bye.